Okay, for this problem, what we need is to solve this, and we see we got a 9x squared plus 4 right here. I don't want to square root both sides. That'd be kind of garbage. And so what I'm going to do is I'm going to take that 12x and subtract it from both sides, zeroing it out. And to make this look like a quadratic, I'm going to put it right in between the 9x squared and the 4. So it's going to be 9x squared minus a 12x. And then we're just going to drop the plus 4. Of course, we can't combine any of those because none of them are like terms to combine. So with this now, we have a quadratic that we can now solve. And if we went about this well, we would say, well, are there factors of the product of 9 and 4? 9 times 4, which is 36. Are there factors of 36 that I can use to find a negative 12? Well, these are the only factors that I got. So none of these are going to work because if I add them together, I get only positive values. But you can see, especially with the 6 and 6 right there, we can make these negatives. And then if I add these, I do end up with that middle coefficient, which is a negative 12, okay? So I'm going to take that negative 12 and split it up into those two factors. And again, these are in x's, but I'm going to have a negative 6x there and also a negative 6x right there. So now I've got 9x squared minus 6x plus 4. And again, the difference being the negative 12 has been split up into the two terms. From here, we can factor by grouping. So I'm going to take the first group. I can see that I can factor out a 3 and an x. And then we can divide. So 9 divided by 3 is 3. X squared divided by x is x. And then negative 6 divided by 3 is going to be negative 2. And then we yanked out that x. We're going to do the same thing with the next set of the next group. And it looks like we're going to factor out here a negative 2. And it's negative because of the leading coefficient there is negative. And then on the inside, negative 6 divided by negative 2 is going to be 3, keeping the x. And 4 divided by negative 2 is negative 2, which we kind of expected because we needed these parentheses here to match. Excuse me. So from here, we can factor out that 3x minus 2 from both of the terms that we have. And then the second factor is going to have what was left over. So that'd be the green 3x, and then the orange negative 2. And of course, this is an equation that does equal 0. So at this point, we can solve, and we see they're both the same equation. They're both a 3x minus 2. And if we could just get one of them, then we'd get the other one, by the way, to equal 0. Then we'd get a true statement. And to solve then, let's go ahead and use purple here. But you'd add 2 to both sides. And you'd end up with a 3x equals 2. Divide both sides by 3. And you do end up with a little bit more space. You do end up with x equaling 2/3. Okay, so I'm gonna test this in my calculator. I'm gonna replace x with 2/3 right here. So I got 9 times 2/3 plus 4, enter, and it says on the left side we get 8, and then on the right side 12 times 2/3 also is 8. So it looks like we have found an actual solution. If you're like, yeah, but there should be 2 solutions. Well, here's what happens is you can solve 3x minus 2 here and here, but you're going to end up with the same answer. So really what happens is you get 2/3 twice, which is okay. What this means is that you have the vertex of a parabola, because this is going to be a parabola. It's going to be a curve, and it's going to touch just barely at the x-intercept, at the x-axis once. So there's our solution, and that's all we really need for this problem right there.